Very good morning to all. Today we are going to see a problem on superposition theorem. So in this superposition theorem circuit, a dependent source is given. So as per the procedure already we have seen in our previous classes, if the dependent sources are given, you need to undisturb. Like you have to take as it is whatever it is there in the circuit. So this is the circuit shown we are taking. So we have to find out the I naught. We have to find out the current across this point using the superposition theorem. So here 4 amps current source is acting. So here resistance source is there. Here again resistance source. Here this loop you have seen dependent sources there. That is 5 I naught is there. And here also one resistor is there. In here also another one sources. So two sources. Okay. So now we are taking just 4 amps alone acting. So we are short circuiting this 20 amperes, and applying the we are taking this particular we are short circuiting this 20 amperes, and we are applying the nodal analysis. So here we are taking this node number 1 V1, here we are taking this node number 2 V2, here we are taking this node number 3 as V3. As the current flow in this direction, that is 4 amps is flowing like this, so here we are taking this I1. Okay, so in this particular node, so the current is dividing. So this current we are taking this I2, and this current is we are taking this I3. And here the current direction is given, that is I naught. In this node V2, we are taking this I naught. So here this current we are taking this I4 like. Just for our understanding, we are taking like this, but we need to find out the what is the current flowing in this particular 5 ohm resistor, that is I naught. We need to find out. So first we are short circuiting the 20 volts, and we are considering only 4 amps alone acting. So applying the nodal analysis at this particular point V1. So applying the nodal analysis V1, that is applying the Kirchhoff's current law. So this current is coming inside. So we are taking this 4 is equal to this two currents are going outside. So we are taking V1 minus V2 divided by 3 plus. So this current is V1 minus V3 divided by 2 ohms. So like that we are simplifying this equation, taking the LCM. Okay, so simplifying this, so we are taking the LCM here as 2 and here as 3, and common LCM is 6. We are taking 6 into 4 is 24, and again simplifying this, so we are getting this 24 is equal to 5 V1 minus 2 V2 minus 3 V3 is equal to 24. That we are taking this equation number 1. Next, in this point, so here we are applying the nodal analysis, that is Kirchhoff's current law again. So here I2, so here this current is I2, here I2 is coming inside, so I naught is going outside, and I4 also going outside at this point. So I2 is equal to coming inside is we are taking this positive, I2 is equal to going outside, we are taking this I naught plus I4, or otherwise in this direction I2 is equal to I2 minus I naught plus I4 is equal to 0, like that also you can take. So here either way you say, so I2 is equal to I naught plus I4 we are taking. So what is I2 here? So I2 is nothing but, so I2 is V1 minus V2 divided by 3. V1 minus V2 divided by 3. Next, what is I naught here? I naught here is, what is I naught? Yeah, I naught in this direction, no? So in this direction, I naught is nothing but V2 divided by 5. V2 divided by 5. So I4 is nothing but, I4 is nothing but, so this dependent source is also there. I4 is nothing but V2. Okay, so V2 minus 5 into I naught. As it is, we are taking, because we are not disturbing the dependent sources, minus 5 into I naught minus V3, because here V2 minus V3 minus 5 into I naught. So we are taking this direction. Okay, current flowing in this direction. So we are taking this minus 5 into I naught divided by 1, divided by this 1 ohms. Next, plus V2 divided by 5. Yeah, plus V2 divided by 5. So V2 divided by 5 is nothing but here I naught. So that is also we are taking I naught is nothing but V2 divided by 5. That is also saying simplifying this equation, taking the common LCM and simplifying this equation, we are getting the final equation as 5V1 minus 8V2 plus 15V3 is equal to 0. Take this as equation number 2. Okay, take this as equation number 2. So next, at node 3, so we are short circuiting this particular 20 volts. So node 3 is nothing but a V3, okay, minus. So node in that node 3, yeah. So V1 minus V2, V3 divided by 2. Yeah, here V1 minus V3 divided by 2. Next, V3 V2 minus 5 I naught minus V3 divided by 1 is equal to this particular part. This particular part is V3 divided by 4. So that also we are taking. So is equal to V3 divided by 4. So taking this three equation, that is V1 minus V3 divided by 2 plus V2 minus 5. So I naught is nothing but V2 divided by 5. So from the previous equation, V2 divided by 5, that we are substituting, simplifying this equation. So we are getting the equation as, yeah, simply, yeah, here I naught V2 divided by 5. So simplifying this equation, we are getting finally as V1 by 2 is equal to V3 plus V3 divided by 2 plus V3 divided by 4. Because V2 and V2 getting cancelled. Here V2 and V2 getting cancelled. So V2 term is neglecting. So V1 is equal to 7 V3 by 2. So or otherwise we can write it as 2 V1 plus 0 V2 minus 7 V3 is equal to 0. Take this as equation number 3. So three unknowns are there, V1, V2 and V3 by using the linear equation method or by using the scientific calculator. You can calculate this V1, V2 and V3. While calculating, we are getting the answer as V1 is equal to 13.176 voltage and V2 is equal to 15.29 voltage and V3 is equal to 3.76 voltage. So these are the three voltages we are getting while solving the equation 1, 2 and 3. Yeah, this is equation 1 and this is the equation 2 and this is the equation 3. While solving, we are getting the so what is the current I naught? Because in the question they asked the current I naught. So I naught is nothing but here if you see what is I naught. So I naught is nothing but V2 divided by 5. So V2 divided by 5, that is Ohm's law. V2 divided by 5, that is so 15.29 divided by V2 is nothing but 15.29 divided by 5 is, so I naught is nothing but 3.058 amperes. Now we are considering open circuit the current source, we are considering only 20 volts is acting because current source we are open circuiting. So next we are going for the mesh analysis. So here one loop is there, here one loop is there. So here if you consider also, because current will not flow in this particular loop because it is open circuited. So two loops are there. So applying the Kirchhoff's voltage law in loop number 1. So 2 into I1, where is, yeah, here. So we are considering from here 2 into I1. If you current comes like this, it is minus 5 I naught plus 1 into I1 minus I2 plus 3 into I1 is equal to 0. So simplifying this, taking common terms outside and simplifying this, we are getting 6I1 minus I2 minus 5 into minus I2 is equal to 0. So I2 is nothing but minus I naught. I2 is nothing but minus I naught. So from the previous equation, because I2 we are taking less like this, but I1 is flowing like this. So I2 is equal to minus I. Okay, so that we are substituting here. Okay, so I2 is equal to minus I naught. So simplifying this, we are getting the 6I1 plus 6I2 is equal to 0. 6 I1 plus I2 is equal to 0, taking this as equation number 1. Next, applying the KVL in loop number 2. Loop number 2 we are applying. Similarly, 1 into I2 minus I1. So here 1 into I2 minus I1. So current is flowing like this, positive to negative. So we are taking this positive 5 I0 plus 4 into I2. Plus 4 into I2. Next, it is flowing from minus to plus. Minus to plus is minus 20 plus 5i2. So here also one more 5i2 is equal to 0. Simplifying this, yeah. So here also, if you take I2 is nothing but minus I. Okay, I2 is nothing but minus I0. So simplifying this equation, we are getting that 5i2 minus I1 minus 20 is equal to 0. Next step, we are taking the, yeah, so simplifying this further, we are simplifying this. So from the previous equation, I1 is equal to I2. So I1 plus I2 is equal to 0. Then I1 is equal to I2 because equal to 0. No? So equal to 0 is, so I1 and I2 is equal to same. So we are taking I1 is equal to I2. So here while substituting this 6 I2 is equal to 20. So I2 is equal to 3.33 amperes. So here, so I2 is nothing but I0. I0, so minus. Okay. So I2 is equal to minus I. So we are I0 is equal to minus 3.33. How minus I0? Na? Current, if you see the question, uh, here we are taking this I2, but the current in this direction we are taking this I2, but the current flowing in the reverse direction. So it is I2 is equal to minus I. So that's why here we are taking I2 is equal to, yeah, I0 is equal to minus 3.33 amperes. So here I0 is equal to 33, only 20 voltage acting. So when 4 amperes is acting, that current also we calculated previous. That current also we have calculated I0 is equal to 3.058. In superposition theorem, so we need to do the algebraic sum. So whichever the current we need to do the algebraic sum. So total current flowing, that is I0 is nothing but I0 when 4 amperes acting, then plus I0 when 20 voltage is acting. So if you add all this two, that is 3.058, that is when 4 amperes is acting, and when 20 voltage is acting, it is minus 3.33. So if you add, I total is nothing but minus 0.272 amperes. So I naught is acting in reverse direction because we are getting as minus. No? So minus means, so I naught is in reverse direction. So in the question it is given as I naught in this direction. But while solving, we are getting I naught in minus. So I naught is in this direction, not in this direction. I naught should be in this direction. So that is the observation we did from the verifying the superposition theorem. That is the answer for this particular circuit given in the